Okay, my dear friends, now we are supposed to start with gravitational effects on orbits. Gravitational effects on orbits. So these things are very common, which we know already very well, but let's continue. No worries at all. So what is this telling? The force acting on an object due to gravitational. What is weight? Weight is defined as the force due to gravity. So force acting on an object due to gravitational attraction or gravitational field, that is weight. Not a big problem. All these things, first I thought that you should study them yourself, but let's quickly move through them, go through them. Both weight of any body and the value of gravitational field strength G differs between surface of the earth and the surface of the other bodies in space, including the moon, because of the planets or moon's mass. So gravitational field strength, it is the force per unit mass. So these things are varying depending on the difference in distances. You can say even it will not be too much difference, but still there will be difference. The weight of a body at the poles and the weight of the same body at the equator, it will be different. This reason earth is not exactly a circular object, it is elliptical to some extent, you can say. So the distance of the body, if it is at the poles, it will be larger from the center as compared to the distance of the object if it is at the equator. So the value of G will vary, and it means weight will vary for the same mass, even because W is equal to mg. So if the value of G will be different at the poles of the earth and also at the equator, so it means the weight of the same body will be different. Like weight for me on earth, roughly let me say it is 750 newtons, and my weight on moon will be 6 times smaller, because the gravitational field strength on moon is 6 times smaller than on earth. So in this way we can differentiate. The gravitational field strength on the gas giant, for example Jupiter, is more than on earth. So this means it will be harder to lift a mass on the gas giant than on the earth. Mean it will be difficult to jump, let me say, on moon, jump upward on Jupiter, as compared to on earth. The reason is the value of G on Jupiter is almost 2.5 times greater on Jupiter as compared to on earth. So these things important, and also we should keep in our mind. Then gravitational attraction of the sun, the gravitational force exerted by the larger body on the orbiting object is always attracted. So force of gravity is always attractive. So if somebody is asking you the difference between force of gravity and gravitational field, force of gravity and magnetic field, so another one very major difference, that force of gravity, it is only attractive force, whereas magnetic force or electric force, they can be attractive, they can also be repulsive depending on the nature of the charges or the poles. So therefore the gravitational force is always acts towards the center of the larger body. Like the value of G on the moon, gravitational force on the moon from earth will be always toward the center of the earth. The gravitational force on my body, it is always toward the center of the earth. But if we are talking about earth around the sun, then the gravitational force from the sun on the earth will be always toward the center of the sun. So therefore the force that keeps an object in an orbit around the sun is the gravitational attraction of the sun, and it is always directed from the orbiting object to the center of the sun. So it is always directed toward the center of the larger mass in universe in general. Like sun is larger in mass as compared to earth and all other planets and the part of the solar system. This gravitational force will cause the body to move and maintain in a circular path. So this is already studied in general physics, where centripetal force we studied. So not a new idea or different idea. So sun's gravitational field and distance, as the distance from the sun increases, the strength of the gravitational field on the planet decreases. That's why the orbital speed of the planet decreases. This we studied even in the last class when we were talking about that why Mercury is orbiting once around the sun in 88 days while Neptune is taking 165 years. So two reasons were there. One is the distance which the Neptune has to travel, it is so long as compared to Mercury. And secondly, Neptune is moving or traveling very slowly, or it is moving with a smaller orbital velocity as compared to the Mercury or other planets which are closer to the Sun. So these are the same things, just they are being repeated. So to keep an object in a circular path, again this is being repeated, it must have a centripetal force. So the meaning of the centripetal force, it means force which is always acting towards the center, and let me say of larger mass, like moon around the earth. So larger mass is earth, so centripetal force will be the gravitational force of the earth on the moon, and it will be toward the center of the earth. And in case of earth revolving around the sun, so gravitational force will be providing the centripetal force which is always toward the center of the sun. So for planets orbiting the sun, this force is gravity, force of gravity. Therefore the strength of the sun's gravitational field in the planets affects how much centripetal force is on the planet. The strength decreases further away the planet is from the sun, and weaker the centripetal force. Again and again it is, because we are not supposed to memorize this formula, but F is equal to mv square over r. So this force is inversely proportional to this distance between the radius of the orbit. If the orbit radius is increasing, so the centripetal force will be decreasing. That's what it is mentioned there. So also centripetal force is proportional to the orbital speed. If the speed will be more, centripetal force will be more. Therefore planets further away from the sun, they have a smaller orbital speed. This also equates the longer orbital duration. Again and again the same thing is being repeated. So I am not just moving forward. This we discussed even last class. Now let's start with this sun and other important things regarding this. If anybody is having the question regarding whatever I was just discussing with you people, so please feel free, you can ask me now. Okay, now sun lies at the center of the solar system. The sun is a star which makes up over 99% of the mass of the solar system. 99% of the mass of the solar system. The fact that most of the mass of the solar system is concentrated in the sun is the reason the smaller planets orbit the sun. So more mass, it means more gravitational pull. So that's why the planets which are with smaller mass, they are all orbiting around the sun. The gravitational pull of the sun on planets keep them in orbit. That's what we discussed few moments back already. Sun is a medium-sized star. Sun is a medium-sized star, and it is not very hot, consisting of mainly hydrogen and helium. Consisting of mainly hydrogen and what? Helium. And hydrogen you can say is the fuel, and helium is the product. It will be coming in our next discussion. It radiates most of its energy. Who? Sun radiates most of its energy in the form of infrared, which you can consider as heat. Infrared, which you can consider as heat. Which you can consider as heat. Visible light, we know it already, and ultraviolet regions of the electromagnetic spectrum. So remember, if there is a question in the exam that name the radiations or electromagnetic radiation which the earth is receiving from the sun, so then answer will be visible light, we know it very well, infrared, which means thermal energy which is being transferred, and ultraviolet, which we cannot see or we cannot feel in general. So these are the three parts of the electromagnetic spectrum in which the sun is majorly radiating its energy. So what are the three parts of the electromagnetic spectrum in which the sun is radiating most of its energy? One is the infrared during the day, all the time in Riyadh or anywhere in the world where there is a day, so infrared heat is being transferred. Visible light is there and ultraviolet radiations are there. These three names you should be very much particular, and I think so this has come in last year exam for 3 marks. In May June 2024 this was there for 3 marks, that name 3 parts of the electromagnetic spectrum which are emitted by the sun or which is received by earth from sun. So these 3 names should be very much particular and you have to memorize them. A star's color is related to its surface temperature. So red star is the coolest, temperature is around 3000 Kelvin. So almost this one or this one is sun, so 3000 Kelvin. And the blue star is the hottest one, up to 30,000 Kelvin. So these are, so the colors of these stars, basically they are giving us about the surface temperature of these stars. Inside the core, that is too high, like even see the surface temperature of the sun can be 3000 to 6000 kelvins, but the core temperature of the sun or the temperature at the core of the sun, my dear friends, that is almost 150 million degrees Celsius, too much high. So these temperatures which are mentioned in this figure, in this image, they are the surface temperatures. It is mentioned over here and it is also mentioned over here. So these are all what? These are all surface temperatures. These are all surface temperatures. Please, if any one of you is having any question or query regarding this, feel free. I will be waiting for you few seconds and then we will be moving forward. Okay, now nuclear fusion in stars. Already we discussed it, but now again. In the center of a stable star, see, not at the surface, center, core of a stable star, hydrogen atoms undergo nuclear fusion. And nuclear fusion is a phenomena which is right now not commercially possible on Earth. Fission is going on commercially, but on large scale, fusion not till now, not on commercial basis. Experimental basis, yes, it is there. So in the center of a stable star, hydrogen atoms undergo nuclear fusion to form helium. Fusion means join together. The equation for reaction is shown here. Just let's hear the Adhan, Maghrib prayer Adhan, then we will continue. Okay, my dear friends. So, nuclear fusion in stars, as we discussed before, in the center of a stable star, main sequence star, hydrogen atoms undergo nuclear fusion, joining together to form helium. The equation for the reaction is shown here, and the diagram is also given, but I will focus more on equation. So, deuterium and tritium, two isotopes of hydrogen, and they join together, and we are getting helium and one neutron. So 1 plus 1 is equal to 2, that is equal to 2 plus 0 equal to 2. So proton number is conserved. We need to check that if any equation is there, it will be viable only, it will be workable only if the proton number is conserved and the mass number or nuclear number is also conserved. Now what about the nuclear number? It is 2 plus 3 equal to 5, and that is equal to 4 plus 1. 2 plus 3 here and 4 plus 1 here, so it is also equal to 5. So equation is workable, correct? Now question is there, which this we studied already, but one thing very important is there. 1H2 plus 1H1, it is giving us 2He3. Again 1 plus 1 is equal to 2, and there is equal to 2, so correct. Then 2 plus 1 is equal to 3, and here is 3, correct. So this equation is okay, but see the possibilities. Which of the following is a valid reason as to why hydrogen fusion is not currently possible on Earth? Currently hydrogen fusion is not possible on Earth. So what is the reason behind that? Hydrogen fusion produces dangerous radioactive substance. No, this is wrong. It produces simply helium, which is an inert gas. Ahmad Abdul Ruba, you people are correct. Okay, inert gas. Hydrogen nuclei require very high temperature to fuse together. Yes, B is the correct answer. And why high temperature is needed, that I will explain. Hydrogen is a rare element. No, not rare element. That would be difficult to get a large amounts of. Hydrogen is the one of the abundant element. He said rare element. Rare mean it is not frequently available. No, it is frequently available. It is one of the most abundant elements which we can get easily. So that's why it is wrong. C is wrong. Hydrogen does not produce enough energy. No, this is also wrong, to be commercially viable. So we are getting huge amount of heat and light even on Earth. That is just the result of fusion reaction which is going on the in the core of the sun. So this is also wrong, that it is not able to produce enough energy. It is produced to, enough is a small term. It can produce enormous amount of energy, which even not measurable if you ask me even. So that's why D is wrong. Now for B, you have to say it 2-3 things. Why high temperature is needed? Now see, hydrogen nuclei. Nuclei is the plural of nucleus. Not only hydrogen nuclei, all elements nuclei, they have positive charge, because inside the nucleus there are protons and neutrons. Protons are positively charged, neutrons have no charge. So protons, positively charged particles. So positive, they repel. So two hydrogen nuclei would have a repulsive force between them. If they have a repulsive force between them, then how we can fuse them? In other words, how we can join them together to make helium? There is a strong force of repulsion. So this strong force of repulsion we can overcome. How? High temperatures are required. When high temperature, it means high kinetic energy. If high kinetic energy, it means they are moving very fast. So high temperatures are required to give to the nuclei enough energy to overcome the repulsive forces. So my dear friend, this is a 3 marks PET question in paper 4. Simply the examiner will ask why high temperatures are needed to execute nuclear fusion reaction or fusion of hydrogen isotope. Then our answer will be hydrogen nuclei has positive charge, so there is a strong repulsive forces, so high temperatures are required to give nuclei enough energy or kinetic energy to overcome the repulsive forces. Then the answers are given that Y is not correct because products of hydrogen fusion which is in the reaction is helium, and helium is an inert gas. We cannot say it is dangerous radioactive material because they said dangerous radioactive waste, which is wrong. C is wrong because hydrogen is very much abundant element, mean it is frequently available, not rare element which is not frequently available. Then it is the most common element in the universe. So answer is not D because hydrogen fusion would produce large amount of energy. We cannot say that it is producing less amount of energy. Please, my dear friends, if any one of you is having any question or query regarding this all, feel free. You people can ask me now. Waiting for your responses. Okay, let's move forward. Next is the Milky Way. Galaxies are made up of billions of stars. The universe is made up of many different galaxies. The sun is one of the billions of stars in a galaxy called the Milky Way. Now we are on Earth. Earth belongs to solar system, and the solar system center is sun, and sun belongs to a galaxy known as the Milky Way. So in other words, we belong to the galaxy named as Milky Way. Now one very important thing is going to come in front of you, which will come in paper 2, which is coming in paper 4 very frequently. What is that? Astronomical distances. Astronomical distances mean very, very, very large distances, such as the distance between the stars and galaxies are so large that physicists use a special unit to measure them called a light year. Now, one very common mistake or common misconception, light year. It looks like it is written year, so it is time. No, not at all. Light year is not the unit of time, but it is the unit of distance, but very large distance. What is 1 light year? See first of all the definition. The distance traveled by light through vacuum of space in 1 year. Light year. Like sun is not at a distance of 1 light year from us because it takes hardly 8 minutes for the light to travel from the sun to reach to earth. So 1 light year, it is the distance traveled by the light as it is moving through the vacuum in 1 complete year. 1 complete year. Another thing again, light year is not the unit of time. Like you consider here it is the unit of time. No, light year is the unit of distance. Which distance? It is the distance which is traveled by light through the vacuum of space in 1 complete year. Now 1 light year is equal to this much. How to get it? Please, this has come in exams in paper 4 even for 3 to 4 marks. We know speed is equal to distance over time. We know light year is a distance, so it means distance is equal to speed times time. Speed of light, a very common constant, that is 3.0 times 10 raised to power 8 meters per second. And time, year, 1 year has 365 days. Each day has 24 hours, each hour 60 minutes, and each minute 60 seconds. Multiply them all together. So 3, then 1, 2, 3, 4, 5, 6, 7, 8 times 365 times 24 times 3600 together. 9, 4, 6. And then how many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I can write it 9.46 times 10 raised to power 15 meters. And we can round it off to 9.5 times 10 raised to power 15 meters. Please, my dear friends, if there is any query or question, feel free. You people can ask me now regarding this calculation of light year. First of all, light year, it is not the unit of time. This is the unit of distance. This is the unit of distance. And which distance? It is the distance traveled by light through vacuum, through space in one complete year. Yes, inshallah. Okay, so this was about the Milky Way and the light year. Now I will be stopping the lesson. There will be a break for Salah and then we will start our lesson again. Stay blessed, all of you.